Hi, I'm Jacob Willett, and this is our ME324 project on thin film solar cells. Alright, first we're going to have Yunzhou Fang talk about how thin film solar cells work.
Okay, so let me introduce how solar cell works. First, we need to introduce two kinds of materials. It's two kinds of the semiconductor. One is called a P semiconductor, and the other is called N semiconductor. The P semiconductor is a kind of material that have vast of have many free electrons, and the N semiconductor is a material that have a lot of the empty space for the free electrons. So when those two materials combine together, those electrons will move from one side to another side, but without any energies input, the electrons will not move freely because there will form a junction between those two semiconductors. When the solar cell is under light, the proton will move the free electrons in the P semiconductor to the N semiconductor. That will form the current. There's two major solar cells on the market. One is called PV solar cell, and one is called CIGS, thin-film solar cell. The PV solar cell is made by silicon, and it's very expensive. It's thick and heavy. And the CIGS thin-film solar cell is much better than that. It's made by copper indium gallium diselenide. Since this is a new kind of material, it's have much more higher efficiency than the PV cell. Since it's thinner, it will be use less materials than the PV solar cell, so it's cheaper.
Now we're going to have Eric Burke talk about the manufacturing of the solar cells.
First step in the process is to load a printing press-like machine with a large coil of aluminum metal. This metal has been thoroughly cleaned with deionized water to ensure the surface is free of contaminants. Typically, the coils of aluminum are over 1 mile in length. As the roll is fed through the machine at 100 feet per minute, it is coated with a micron-thin layer of copper indium gallium dicyanide ink, or CIGS for short. After the application has been made, the coil is then heated to dry the liquid film. During this process, the liquid is converted into a semiconductor. As the dry film exits the machine, a press shears the coil into small rectangular cells. Each coil contains about 50,000 cells. Once the cells are made, they are assembled by robot into large solar modules. The module has a thick glass layer to protect each cell from weather. At full capacity, a solar module is made approximately every 10 seconds.
This has been our ME324 project on thin film solar cells. Thanks for watching.